Okay, this is the use and apply section. And we're asked to complete a table of values for an exponential function, something raised to the power of x, so where x is the exponent. So, anything raised to the power of 0 is always 1. 0.8 to the 1 is 0.8, 0.8 to the 2, that's 0.8 times 0.8, which is 0.64. 0.8 cubed, let's put that in. So, 0.8, which button do I need? It's this one. Cubed equals 0.512. So that's what I'm going to put in here. 0.512. Which, I mean, when you're plotting it, you'll probably have to just, try to get it at 0.51. That would be quite a good effort. So, so the next bit is, so that there, I've got a mark there. Draw the graph of this for values of x from 0 to 4. So, once again, I mean, you had proper graph paper, I've just got some squared paper. Right, now I know that for my y-axis, I'm not going to go down lower than 0, and I'm not going to go higher than 1. So I'm just going to break it down into, I'm going to give each square 0.1. So 0.1, 0.2, 0.3, I'll spare you the going up in 1. There you go. And then on this axis, now I mean I can choose, how I want to split it out. I think I might go for 1 every 4. So here's x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, and I've got it. Okay, so all I need to do now is plot it. 0 on the x is 1 on the y. 1 on the x is 0.8 on the y. 2 on the x is 0.64, so just before, just low, just less than halfway up that. Try to be accurate. 3 and 0.51, so just tenth of the way up there. I'm going to go for there. And 4 and 0.41, so 0.41. There we go. So that is my typical exponential curve, either like that, always going through 1, either like that or like that. So never quite reaching 0 in terms of y. But I can just join this up with a nice smooth curve now. Again, you'll use a pencil. I'm just using a pen so it shows up nicely. Try to draw it nice and smoothly, accurately as you can. You will be allowed a little bit of margin of error. I got this a little bit wrong here. It went a bit too high there. You can see the error in my line there. It should have carried on a little bit lower and gone right through the point. But you'll get away with that certainly in an exam. Okay. So use your graph to solve the equation 0.8 to the x is equals 0.76. So when it's 0.76, which is here, I'm going to read across. Now I'm going to read across. So you draw across from 0.76, just a bit higher than 0.75 to there, and then I'm going to go down from there. So I think it's about there. So I'm saying that when is that equal to 0.76? When x equals just a bit more than 1 1/4. Sorry, you can't see that very well. Move it up. When is y 0.76? So when is this equal to 0.76? When x is just a bit more than 1 1/4. So I'm going to say about 1.28. So x equals 1.28. Now, again, you've got margin for error. I don't know if that is, perfectly accurate, but you'll certainly be allowed anything from, let's say, 1.2 probably to 1.35. I would definitely think you'd be allowed that kind of range. Let's move on. Got a graph transformations question, which is really, really straightforward if you know your graph transformations. all that's happened is that it's been shifted. Here's my y equals f of x, and it's been shifted 4 to the right. And you know that a shift 4 to the right is going to be y equals f of x 4 to the right minus 4. And that's it. Okay, you've got marks in the bag. I just want to take just a moment to explain why it's x minus 4, not plus 4. Right, imagine this, if this was an x squared, y equals x squared curve, which it sort of looks like. Well, if x was 4, okay, and if it had an x minus 4 curve, then 4 minus 4 gives you 0. So 0 squared is 0. So it's the value of x. I would need to take 4 away from this value to get 0, so that when I squared it, it would still be 0. Okay. It's probably best explained with another example. If you're still not sure about why this is the case, either come to Study Club if you want further information on it, or look at a Corbett Maths video, or ask me a bit more about it. Thank you. And that's the end of our use and apply section. So we're going on to apply and problem solve next.